In exercise 3.3, we're going to be quite often factorising by completing the square. Now that means we've got to make this term in x a perfect square, and to do that, what we do, we halve and square the coefficient of x term. So it becomes x squared minus 10x, and plus halving it and squaring it is 10 over 2 all squared. Now because I've added that in, I've got to take it away again. So that becomes x squared minus 10x plus 25, minus 25 takes 7. And that therefore means x minus 5 squared minus 32. Now we can see that this takes the form of the difference of two squares. A minus b, a plus b. So that therefore is equal to x minus 5 minus root 32. Lots of x minus 5 plus root 32. 32 is 16 lots of 2, or 4 root 2. As my answer. And I'll be working through the rest of the questions set along these lines. Now please get used to the completing the square method. It will come in very, very handy as we work through the rest of this particular unit. Now B's a fair bit messier, I'm afraid. What I'm going to do here, I've got to take a common factor of 3 out. Now, what that means is when I halve and square the coefficient term of the x, that gives me 7 over 6 all squared plus 1 take away the 7 over 6 all squared. So I'm left with 3 into x plus 7 over 6 all squared. Take away 1 minus 49, negative 48 over 36. I made a little bit of an error there. That should have, of course, been minus 13 on 36. So what we've now got is 3 into x plus 7 on 6 take root 13 on 6, lots of x plus 7 on 6 plus root 13 on 6. So x plus 7 take root 13 on 6, lots of x plus 7 plus root 13 on 6 as my answer. Quite a messy, yucky question. And out of the blue, we've got this question. Now, this is of a perfect square formation, but it's root 5 x minus 3, lots of root 5x plus 3 as my answer. So difference of two square cases.